Hey, welcome back to the shop. Judging by the views on my last Chinese teardown video, the 5C horizontal vertical indexer, there seems to be quite a lot of interest in affordable equipment. And this thing is a very affordable 5C collet chuck for the lathe. It's obviously made in China, and I got it from one of the usual suspects that sell Chinese tooling here in Germany. I'm not going to tell the name because it doesn't matter. If you do a Google search on 5C collet chuck, you will find hundreds of sellers for these guys. They all look the same. And obviously I had to machine a backplate so it fits my lathe. And I'm quite happy with it. It's well made from the outside at least. Runout in the taper is pretty much zero. Runout with the El Cheapo collets, I got a $150 collet set from 3 to 26 millimeters in 1 millimeter increments. The runout on the part is close to the collet. It's less than 1/100th of a millimeter. It's about 6 to 8 thousandths of a millimeter if you clamp a ground part, or a cylindrical ground part. And out here, about 120 millimeters out, it's about 2/100ths of a millimeter. This is a bit different than a 5C collet nose, where you have the drawbar with the collet thread through the spindle. This has a pinion or a worm gear. I think it's a pinion and bevel gear drive that rotates the thread on the inside, and you just open and close this like a normal 3-jaw or 4-jaw chuck. Clamp your part and you're good to go. Nice thing about these is you don't need a 28 or 30 millimeter spindle bore. My lathe has only a 21 millimeter bore. I could not fit a drawbar for 5C collets because those have about 30 millimeters outside diameter or something like that. So that's the alternative. The drawback to this is you have to crank about 1.21 million times to get the collet out the chuck. I'm pretty sure going to make a 10 millimeter to 1/4 inch adapter to go in my cordless drill, so I can use the drill to change collets faster. And those are the El Cheapo collets. So let's get this off the lathe and take it over to a bench and take it apart. On this lathe you have 3 nuts on the back side of the chuck and a bayonet disc. You give it 1/10 of a turn and then you can just pull the chuck off. And that's the back plate for the 5C collet chuck. So let's go to the bench. Okay, over at the bench, and first we're going to take off the back plate. Keep in mind I machined the back plate myself. You don't get it with the chuck, you have to make your own to fit your machine. The back plate is pretty simple. It has a register here that fits the diameter on the lathe perfectly, and it has a register here to fit the collet chuck. But I machined the diameter of this register 5/10 of a millimeter smaller, so I can indicate the chuck if I need to. If I clamp something up and for some reason 2 diameters don't line up exactly, for example, I can loosen these 3 bolts and then I can knock the chuck on the back plate around until I get perfect runout wherever I need it. But once set to 0, normally I would not have to change anything on the chuck. But it's a nice feature. if you wonder about these 4 screws, I didn't have a piece of continuous cast iron big enough, so I screwed together 2 pieces. In fact, they are screwed, glued, and not welded, but they are screwed and glued together on full surface glued. 4 screws with Loctite 648. They're never going to come out. This is as good as a solid piece. And these are the standoffs that goes through the spindle flange. But now for the really important or interesting part, the chuck itself. At first when I looked at it, I was a bit puzzled how to take it apart, because there is no back plate that you can take off and there is no obvious seam here. Then I took a closer look and I noticed a very, very faint split line along the center of the pinion. Then I realized that these 3 screws hold on the rear plate as a whole. So let's take out these 3 screws. Those are rather tight. There are also 2 retaining screws for the pinion. While I'm at it, I'm going to remove these 2. Let's see if we can get this guy apart. For that I might drop the screws back in. Okay, there we go. There we go. Okay. Oops. And this. And wow. And this looks pretty good. There is no dirt in it. At first glance, at least. And as I guessed, this is a rack and a bevel gear construction, just like a normal 3-jaw chuck, only that we don't turn a spiral. We have a bevel gear with the internal thread that matches the 5C collet, obviously from the other side, but that's the thread. And when you turn the pinion, you're turning the bevel gear, the big bevel gear with the thread, and you pull in the collet. So this looks all pretty good. Looks very nice. Okay, there are a few burrs, but surface finish on these mating surfaces is surprisingly good. And ooh, did you hear that? This sounds at least slightly hardened. Let's get the bevel gear out. Oop, there we go. Okay, that's bevel gear. I suspect that this guy is super hard. Yeah, this is hard. And this is the tapered spindle nose with the carrier for the bevel gear. There is a single pin here that aligns the 2 parts together. I think they machine them as one, and then they take it apart, put in the gear, and are done. So they need the alignment pin so it's accurate if you take it apart and put it back together. Makes sense to me. Yeah, I'm I'm really surprised. Look at those surfaces. You can't bitch about that surface finish on the mating surfaces. What you can bitch about are some of the apprentice marks here looks like somebody got to work with a beaver to deburr some pieces. But apart from that, I'm surprised, and I like it. There is the anti-rotation pin on the inside for the 5C collet. You can access that from the outside via the set screw in case you shear it off. Okay, while we're at full camera angle, I will check the hardness on these pieces. Let's go with 65 Rockwell. I will check it here on the inside, close to the... There is a relieved surface on the inside, close to the taper for the collet and close to the rear diameter for the collet. And that's the area where I'm interested in. And the 65 Rockwell file grabs. The 60 Rockwell file grabs too. And the 55 seems to slip. Okay, 50 doesn't grab at all, 55 grabs barely, so this chuck is very much on the 55 Rockwell side, which is not too bad. I think I can live with that. So spindle nose has 55 roughly. This gear has... Okay, same with the bevel gear. This is also 50, 55, more on the 55 side, which is also, I think, okay. That's file hard. A normal file would have a hard time to grab it without damaging the actual file. So I will bring you in a bit closer for some of the surfaces. Okay, this is the bevel gear. As you can see, this is the rear surface, the thrust side. This is where all the axial pressure goes into it, and these two surfaces are nicely ground flat. As I said, 55 Rockwell. Outside diameter is ground, but the teeth of the bevel gear are unmachined. At a closer look, I would almost say that I don't see any machining marks on them. I think that they are forged. That this whole piece gets forged in a die, part of the teeth falls out. Then they just tap it, harden it, and grind the sliding surfaces off it. That would be a very fast way to make this part. And the thread in it fits. I don't know how much play the thread on a high quality chuck has, but yeah, that's not horrible. That's okay. The rear plate looks also pretty good machined. Only the bores for the pinions look like they have been cut with a dull beaver. But apart from that, nice surface finish. Yeah, that's not too bad. I like it. I'm even lacking the motivation to drop the parts in the ultrasonic cleaner because I didn't find any grinding dust in this guy. Just give it a wipe down and replace the grease with some moly grease because I can. Okay. That's okay, running quite nice. And we got it back on the backing plate. I'm not cranking down on these screws yet because I have to set the run out when I get it on the lathe. Then I can crank these screws down. So let's go to the lathe. Okay, now with the chuck in place, I have to set the run out once. Okay, keep in mind the screws for the back plate are not tightened down. I'm just going to spin the chuck and find the high spot like this, and okay, this is pretty good. Let's tighten down the screws a bit more. Okay, this is about, this feels like 0.004 of a millimeter. That's quite good. Okay, let's bring this in a bit better. We're pretty much at 0 here. Yeah, that's what I like. That's what I'm talking. Let's tighten the screws finally down. That's what I like. Okay, I got a 10mm dowel pin in the chuck, and I'm about to check the run out over a distance of 70mm roughly. And you can see that we don't get much run out at all. That's not too bad for beginning. And when we move to the outer end of the dowel pin, we get about 1/100th of a millimeter, and that's, for me, for the price point of this chuck, this is well below 300 euros, this chuck, way below, and that's absolutely acceptable for me, for the class of work I do. If I would do real tool die or mold work, I would hesitate to buy something like this, but that's not the class of work I do. I'm no tool die maker. So my verdict on the 5C collet chuck is rather good. You saw the internals, there was not much dirt in it, pretty much no grinding dust, no crap. It was well lubricated. The fact that I changed the grease to something else is just my personal decision. All the surfaces are nicely machined, and even the gap where I opened the chuck, this you can't feel it anymore. This closed up back again very nicely. The heat treatment seems to be okay. 50 to 55 Rockwell is not super hard, but for the amount of use this gets in my shop, should be okay. It operates quite smooth. That's something that's pretty nice. Can't say anything against that. Overall precision seems to be very good. Result I got with the 2000th of a millimeter indicator are very, very promising. I think this thing, as a lot of turning work I do is diameter 20 or smaller, so this thing will get quite a lot of use. For some reason I don't do a lot of long shafts. I do either small diameter parts or disc shaped parts. So for disc shaped parts, of course, I have the 3-jaw chuck and the magnetic chuck. And for my small diameter turning, this will come in handy. So, and also the nice thing on the 5C is you can get emergency collets that you can machine to any diameter. You get backstops that screw into the collet and a lot of more square collets. You can get everything you want for these. So it's will be a nice addition. Hope you enjoyed this small teardown. Wasn't very long, but maybe it's interesting. Thank you all for watching and see you next time.